Hello everyone, I'll be doing a presentation on stress analysis in the natural environment, biomechanics of trees and trees. Trees have several ways to cope with stress in their environments. These include their structural adaptations, that is, their branches, leaves, and stems have been adapted to cope with the different intensities of wind that affect their stability and may cause stress, hence making them to break or bend. There's, the trees have evolved a range of structural adaptations to cope with these stresses. Some have barks that are strong enough so that they can allow distribution of load evenly in the tree so that in case of excess wind it can't break. It may bend, but it will spring back to its normal position after some time. The trees also, their branches also have a good flexibility so that when there is excess wind, it can be swayed around, but it cannot cause them to break or bend permanently. They also have a good load distribution, that is, the branches and the leaves have been distributed well to allow even distribution of stress within the tree. This distribution enables the plant to survive without breaking or even bending permanently in case of excess pressure applied on one point of the tree, maybe by an animal swaying on the branches or by excess winds and rainfall, or maybe like a hurricane. So you can see this tree has its branches and leaves well distributed on the top part of the tree so that the force and the stress exerted on the lower part is even and can be able to withstand excess stress and strain. We also have the torsional stress. This is the stress that happens on the tree branches when it is subjected to wind or any other lateral force. This stress may cause the tree to break in case of excess wind, and in case of excess wind and excess stress exceeding the stress which the tree can withstand. It also has back protection. Their backs are strong, and this acts as a protective layer. It is structured so as to distribute stresses evenly within the tree. The bark's composition and thickness vary with trees to protect against physical damage and other environmental stressors. As you can see in the image, there is the original configuration of the tree before the wind, and after the wind we can see that the tree is bent a little to the sideways. The one side of the tree is experiencing tension, that is the direction on which the wind is blowing it from, and the other side is experiencing compression. If the tree does not have enough strength, if if its bark and the stem cannot withstand the force caused by the wind, the tree may end up falling down or even getting broken at the section where it's bent a little. Also, we have the root system. As you can see, there's a picture of a dense root system. The root systems undergo stress analysis. Their growth and structures are made such that they can optimize the tree anchorage to securely in the soil. With a good root system, it ensures stability in case of any external forces such as wind and soil movement. Soil movement may include effects such as earthquakes. In case of earthquakes, trees may, that is mild earthquake, many trees may fall and some may withstand the stress that is caused by the earthquake if they have enough a strong enough root system. Some plants also have prop roots. e.g. the maize plant, so that in case of excess wind, the prop roots help the plant in maintaining its stability and hence preventing it from falling down. We also have other responses to environmental stresses such as hurricanes and excess rain. Trees also shed leaves or undergo a controlled stress to prevent uprooting or branch breakage. There, there are many trees also which have adaptation to the environment, such as in the presence of light, the branches tend to grow towards the light. This is to ensure that its stability and strength is maximized. They also have evolutionary adaptations, which enables them to cope with stresses present in their natural habitats. Biomechanical modeling of trees enables the trees to survive in their different environments without undergoing any damage such as breakage or bending. This breakage and bending may be caused by plants, by wind, and also by animals that live in the plants. In summary, stress analysis principles are essential in understanding biomechanics of tree branches and leaves. Trees evolve their structural adaptations to cope with environmental stresses, and these adaptations are as a result of natural stress analysis over the many years that the trees exist. By applying these principles, scientists and ecologists gain insight into how trees maintain their structural integrity and adapt to their surroundings. So you can see the plants have to adapt so as to survive in their natural habitat. They have to develop branches and leaves that are strong enough to withstand the stresses caused by the factors in their natural habitat. Thank you.